Alright, we're gonna go on an adventure, which you know because the moon is out, there's Mathceratopses everywhere. This is gonna be fun. So, proportions. Two ratios are proportional if their values are equivalent. Now, a ratio is a comparison between two numbers, and you can see if they're equivalent. So let's look at a table of values here that records two different measurements, and we'll set up these ratios and then see if they're proportional to each other. So I have a table of the body width of the Mathceratops in meters, and then the value of its height, his height, excuse me, in meters. So uh, these are my data points for each of the three. Okay, so this first guy here, let's call him 2 meters wide and 1 meter high. This guy, let's call that 4 wide and 2 high, and then the width of this last one, say eyeballing it, looks like 8 meters across width and 4 meters high. So the question is, are these Mathceratopses proportional to each other? So these are ratios. So I could write the ratio of the width to the height of the first guy as 2 to 1. Okay. You can also write ratios as like that, 2 to 1, but and it's much easier to deal with them as fractions. So first one is 2 to 1, second one is 4 to 2, and the third one is 8 to 4. And the question is, are these equivalent ratios? Do they have the same value if you reduce them down? So one way to do that is to um, just find the decimal equivalent of each fraction and see if they're all the same. So I'll just get out my calculator. So 2 divided by 1, 2 divided by 1 is 2. Probably don't really need a calculator for that. 4 divided by 2 is 2. 8 divided by 4 is 2. So the decimal equivalent of each of these fractions is all 2. So they're all equivalent ratios. Another way you could do that is just simplify the ratio. So this one is as simple as it can get. But 4 to 2, um, you could you could find the greatest common factor. So the factors of 4 are 1, 2, and 4, because 1 times 4 is 4, 2 times 2 is 4. And then the factors of 2 are 1 and 2. 1 times 2 is 2. The factor they share in common is 2. So you could divide each number by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. So if I simplify this ratio, I get this, the same thing. If I simplify this one too, the greatest common factor of 8 and 4 is 4. So if I divide 8 by 4, I get 2. And if I divide 4 by 4, I get 1. So they had all reduced down to the same ratio, 2 over 1. Or if you want to just divide, get the decimal equivalent of the fractions, you just divide the top by the bottom and see what value you get, 2, 2, and 2. Okay, so these are proportional. And you can see visually that these Mathceratopses are proportional. They whatever their width is, the height is something that corresponds to that nicely, so that you can see that they're all the same shape, even though this one's bigger than this one, and this one's bigger than this one. So let's look at some examples of some non-proportions. These are non-proportional Mathceratopses, and here's how we know. So we've got the measurements, the width to the height, and actually let me clear off the space here. So the ratio of the width to the height of the first one is 1 to 3, and the second one is 5 to 2. And I just eyeballed these, so if this guy looks pretty skinny, so width is 1, and then if that's 1, its height is about 3 times that, and if that's 1, then this is about 5, and if that's 5, then the height is about 2. Just kind of eyeball it, and these are not exact measurements, of course. I mean, these are just on my computer screen. I didn't get out a ruler or anything. Just eyeballing it to give you some examples. And this guy, he's really wide but really short, so I called his width 7 and his height 1 meter. Okay, so the question is, are these ratios proportional to each other? You can already see in the pictures, they're not proportional. Uh, but let's prove it. So you can find the decimal equivalent of these fractions. Let's just do that. 1 divided by 3 is 0.33. Repeating. Let's see, what about 5 divided by 2 for that second ratio? That's 2.5. And then 7 divided by 1 is just 7. So 0.33 repeating is not equal to 2.5, which is not equal to 7. So these ratios are not equivalent, so they are not proportional. Now what if I actually gave you a graph of some ratios? So these are actually visual representations of the ratio of body widths to body height. And I could just, instead of giving a few measurements, I could give you a line that has an infinite number of measurements that always shows whatever the width is, here's what the height is. So we could figure out, are these ratios proportional? So let's look at the first one, line A. So let's see if this line of Mathceratopses is proportional, if it shows a proportional relationship between width and height. So what you need to do is just pick out a few points on the graph. Let's just say that one, I don't know, that one, why not? And that one. So we write the coordinates of those points down. So here in this table I'm going to put the body width measurement, and then in this part of the table I'll put the body height. So the body width is on the x-axis and the body height is on the y-axis. So let's just record these points here. So this point here is, the width is 3 meters and the height there is also 3 meters. Okay, on this point the width is 4 meters and the height at that point is also 4 meters. I'm seeing a pattern here. Are you? 1, 2, 3, 4, 5, 6. So this point is 6 meters wide and 6 meters tall. Okay, so we've picked out 3 Mathceratopses and written down their measurements. Now we want to see if these ratios, the ratios between the width and height, are proportional. So to do that, we can write out the decimal equivalent of each one. So this is 3 over 3, 4 over 4, and 6 over 6. So if I divide 3 by 3, I get 1. If I divide 4 by 4, I get 1. If I divide 6 by 6, I get 1. So the decimal value of each of these ratios are all equal. So I know that these measurements are proportional. Okay, let's look at the other line. Alright, let's pick out a couple points on line B that shows a different species of Mathceratops, I suppose, and as we can see if the ratio of their widths to their heights are all proportional. So I'll just pull out, I don't know, let's just mix it up. Okay, it's 3 points, and then let's record what those measurements are. So on the x-axis we've got the body width. So on this point, the width of that guy is 2, and when his width is 2, his height is 6. And here, this guy, his width is 4 meters, and when he's 4 meters wide, he's 8 meters tall. I mean, this is a big guy. This guy's 7 meters wide, and when he's 7 meters wide, he's 11 meters tall. So let's find the decimal equivalents of these ratios and see if they're all equal to each other. So 2 divided by 6 0.26 is equals 0.3 repeating. What about 4/8? 4 divided by 8 is 0.5. It's 1/2. 4/8 is 0.5. Wow, that's the craziest 5 I've ever seen. 0.5. So this is 4/8 is 0.5, and then 7/11ths. 7. I don't know what that one is. 7 divided by 11 is, wow, that's nice. 0.63 repeating. So the decimal equivalents of these ratios, 0.3, 0.5, and 0.63, they are definitely not equal to each other. So the ratios of the widths to the heights of all the Mathceratops on this line are not proportional to each other. And as you'll see, any line that's a straight line that goes through the origin here is that's proportional, and any line that doesn't go through the origin is not proportional.